Good morning, Team 5 kiddos. Yes, back for another day. You did a nice job yesterday on your lesson 10-7. I was really pleased with what I saw you guys are doing. Today we're going to be working on lesson 10-9, which is surface area. And it's actually a capital S, much like we had a capital V for volume and a capital A for area. Capital S stands for total surface area of a 3D figure. So what we're going to be doing today is calculating and finding, hey, what is the total surface area of this entire shape? It's different than volume. We're just finding the area of each face, and then we're going to add it all together, right? And I'm going to show you 3 different ways to do that. Okay, the first one I'm going to show you is called the net. The net. Okay, well, first of all, what's a net, Mr. K? That's a great question. Let me show you a net. This is a representation of a net. And this is one of our grad standards that we're working on. We have to be able to calculate the surface area of a 3-dimensional figure using a net. Another thing that they're going to ask you along the way is, what does this net fold up to be? Well, this particular net, if you look closely at it, has 2 squares and it has 4 rectangles. Okay? And if you fold it all up, like so, it goes like so, and makes a 3D rectangular cube, which fits into this nice little handy box. All right, I know you guys wish you were playing with these toys. All right, I know Mariella's out there going, gosh, I really wish I could play with that. Anissa's out there doing the same thing. So don't worry, they're a lot more than just you two, okay? Anyways, so with our net today, I've got a problem here for us to figure out, and it looks a little something like this. When you go to figure out the net using this method, you'll see that each part of the figure of the net as it's laid out has a letter to it. All right? It goes A, B, C, D, E, and F. And in this method, we're going to just calculate the area for each of those shapes. Now, this particular shape, we have all rectangles, right? So it's just area equals length times width. Pretty easy. So if we start at A, we have A, so its width here is 2, and its length, there's not a number here. Where could I possibly find that number? If there's not a number here, where can I look? Well, I'll look down below. Here's one right here. So this line is the same length as this line, so it also must be 6 meters. So length times width, so we have 6 times 2, and that's going to get us 12 meters, right? A total of 12. So I go over here to my A, and I write 12. Now, so A's done. We can cross A out. Done. Or I can write 12 in there and circle it. Just tells me that it's done. Letter B over here, we have length and width. We have a 2 by 2, or 2 times 2 is 4. Write 4 in there, circle it. I'm going to come down here to my B and put my 4 here. Go to C. Hey, C looks a lot like A. Matter of fact, it is. So I don't have a 2 here, but I look over here and here's a 2. So this is a 2 also. And then my 6 is right there. All right, so 2 and 6, 2 and 6, it's the same. So this is a 12. This is 12 meters also. So we're going to write that 12 here. And then we go over to D. And oh, there are no numbers here. Oh, panic, panic. What am I going to do? Oh, wait. They're the same ones as over here. So this is 2 meters. And then this one's also 2 meters. Right? Because it's the same height, and it's the same width. And so once again, 2 times 2 is 4 meters. Oh, it's by these are meters squared. If I didn't say that, meters squared. So I'm going to add that 4 over here like so. Now I'm going to go to E, and E looks a lot like C and A, and guess what it is? It's also 2 meters. Do you see how I'm writing these numbers in? That's okay to do, and you should do that. All right, so we have 6 meters times 2, and once again we get 12 meters squared. And we're going to add that over here on our E. And then lastly we have F, and F is exactly the same. Here we have 2 meters, here we have 6 meters, and so we get 12 meters squared when we multiply 6 times 2. And we add that down here. So the last thing we need to do is sum all of these up. Now there are a couple different ways we can do this. We can add them all up with a calculator, or we can take and do it, use that word we call multiplicatively, right? We can take numbers that we have in common, or 1, 2, 3, 4. We have 4 12s, right? And we can multiply 4 times 12. And we're going to get 48, right? So that takes care of F, or E, C, and D. So we have a total of 48 there. It just leaves us with D and B, which are 4 plus 4 is 8. So we take and add that 8 onto our 48. We're going to actually end up with 56 meters square. And that is how you do a net.